Good morning. Today we will gonna start another topic in design and algorithm subject, that is DP approach. The approach name is DP and the full form is dynamic programming. It's a topic of your unit 4. So what is the DP approach basically? It's based upon the idea that it's characterized in the 4 parts. That first you need to characterize the structure of your optimal solution. Then you have to define the recursive value for that optimal solution. Then compute the values in the bottom-up manner, and then backtracking to construct that optimal solution from the computed information. That is the main approach on which your DP algorithm works. DP is an approach basically which is used for your optimization problem. Now, what is optimization's problem? Optimization problem are those generally in which you need to either to maximize the something or you need to minimize. For example, if we're talking in terms of the profit, then you have to maximize. If you need to talk in terms of the cost, then you have to minimize it. In this way, the DP will gonna approach will gonna work, and it always ensure to give you the optimal solution, although the some other approach are also there, like greedy is also there, but it will not always guarantee you to give the optimal solution, but DP will give you the guarantee to give you the optimal solution just because of the recursively defined function here, because it will recalculate the value at each and every level and consider the only the optimal one. That is why it always guaranteed you to give the optimal values. Now, what are the elements of DP? It normally asked in the exams, like what are the elements of DP? So the two elements of the DP are the optimal substructure and the overlapping subproblem. Now, what is optimal substructure? Optimal substructure property says that the optimal solution you will get for the global at the global level only when the optimal solution you will get for the subproblem, because problem is divided into subproblems. If the subproblem give you the optimal solution, and only the main problem will give you the solution for the optimal for the final main problem. That is how it's considered, and that's why it's guaranteed you to give the optimal solution, right? For any of the problem. That's why the name is optimal substructure. If the optimal value we will get at the lowest structure, then we will get it for the global structure also. For the main problem structure also. That's why the optimal substructure. Substructure means the subproblem. For some problem, if you get optimal value, then you will get it for the final value as well, right? And it says overlapping subproblem. Now, what are overlapping subproblem? It says in the divide and conquer, we have studied like problem is divided into subproblem, right? If a problem is divided into subproblem, then it means that either the subproblem are dependent or independent. If we are talking about the divide and conquer, then these subproblems are they are not dependent on each other. They are independent in the divided conquer. But in the dynamic programming, they are dependent on each other. So that's why they are overlapping in nature. They exist in overlapping in nature. That's why we say the main element of the DP is overlapping subproblem. The space of the subproblem must be small and the recursive solution is there. So it will be used in the calculation of the upper level. So the each subproblem is dependent on the other, so they are overlapping in nature. Usually they are polynomially managed subproblem, and we can revisit the same one over and over again, and that's why the subproblems are overlapping. Let it respond. Today's algorithm which we're going to study, that is fluid partial. Fluid partial is all pair shortest path, and it is based on DP approach. Will the all pair shortest path means it will provide you the shortest path for each node to another. If you are having 5 nodes, then 1 to 5, from first node to all the rest 5, from second to all the rest 5. That's why it is all pair shortest. Right. Let it. Now, what does it say? It uses a dynamic programming formulation to solve the all pair shortest path on a directed graph. That is a graph consisting of the edges, and the complexity is running in VQ. We'll see why it is VQ. And it says no negative edges may be present, but let's consider it's not there. We're assuming this in this problem. Now, what is the structure? In the structure, it says there is a approach which work in the flood partial at intermediate vertices. The whole algorithm considering the intermediate vertices is based upon the concept. Now, what are that intermediate vertex on a shortest path? So let us see first. How does it work? It says let the vertices are V from 1 to N and consider a subset from 1 to K. Like if we are considering any of the path, like see here, there is a vertex I to J. In a given vertex I to J, there are two paths, either a direct path from I to J or an indirect path via K. So that path which is considering the K intermediate vertex via K, this is called your intermediate vertex. So we will gonna see okay, how many number of intermediate vertices are coming in their path. There is only one, that is K. Might be the two intermediate vertices are coming in between the path. If the two vertices are not having a direct path, then is there an indirect path which are uh, coming via any of the intermediate vertices? We're going to see this, right? So we need to find the which path is occurring with the minimum cost. We will considering that one. That's why the shortest path. Now, what is the recursive solution for this problem? In the DP, for each and every sub problem, there will be a recursive formula. The recursive solution is mandatory in BP for each and every problem. So in the Floyd virtual, it also give a recursive formula like Dij, that's the distance from I to j. D means distance from I to j. It is defined if k is equal to 0, it means there is no intermediate vertex. If there is no intermediate vertex, then the original weight, that is from I to j, Wij, that is the minimum. But if k is equal to 1, it means if single one intermediate vertex is in between the two vertices, that is from I to j, and considering that k, then what is the minimum one we have to identify? Whether direct path is the shortest one, that is from I to j, Dij, then we will take this one. Else, the distance from I to k is the shortest one. So di to k plus dk to j. I say k ka path and then k to j path. That is the shortest one. We will need to consider this one. In this way, we need to construct the matrix in this for the given problem, and the matrix name is Bn. N means n is the vertex that is considered as an intermediate vertex here, and pi is the matrix for the ancestor, that who will be the ancestor of which node, that will be defined in that pi matrix. Initial matrix which will gonna form, that is pi node and d node. D node means the initial for the, this is the initial distance matrix for the given problem, and pi node is the initial ancestor which are defined in the given problem. After considering the intermediate problem, after considering the intermediate vertices, we will going to update them, right? Now, this is a fluid virtual algorithm. How does it work? Like it says, whatever the weights are given, initialize them in rows, and then whatever the weight are given, store them in D node. So initial matrix D node will have the initial weight that will be defining our problem. Then we are having for loop from 1 to n. They will be working recursively, one inside another, and inside the three loop, what we are having a Dij. Now, why we are having this for loop? Because we have studied in your matrix multiplication. If you are multiplying the matrices, then you are having the three loop, right? So it is a considering that same formulation. So that's why Dij is a recursive formula that is working inside the three loop and work till n, I will work till n, j will work till n. So the overall complexity we will see that will be n cube. So here n are the number of the vertices. So the overall complexity will be big of b cube in this problem. Right. Now what is dij of k? Distance from I to j via k. What will be that? It will be considered as the minimum that the initial path that I to j is the shortest one, or the via intermediate vertex via k is the minimum one. We will see that one, which will be minimum. We will gonna store that value in the ij, and we will return the dn matrix. For example, if we have five vertices, then we will have d1, d2, d3, d4, d5 matrix we need to form. If we are having three vertices, we have to form d1, d2, d3 matrix here. Respect to the D1, we will have pi 1 matrix. Respect to the D2, we will have pi 2 matrix. Respect to the D3 matrix, we will have the pi 3 matrix. Pi here represent the ancestor, who will be the parent of which one. Now see, this is a given problem. In the given problem, the 1 is connected to the 2, there's a direct path. 1 is connected to the 3, there's a direct path. 1 is connected to the 5, there's a direct path. But 1 is not connected to the 4. So in the initial matrix, we will put here infinity, that 1 to 4, there is no path defined, right? And this we will gonna write here. D note and pi note. Like 1 to 1 self distance is always 0. So in the we will see in the diagonal there is always 0, the distance matrix. Now let's see. 1 to 2 there is a weight incurred with the 3. That is the minimum we will define here. Then we will see 1 to 5 there is minus 4. We have defined it. Then 1 to 3 there is a 8. We have defined it, right? But 1 to 4 there is no direct path, so we will write here infinity. Similarly, this is for 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. One path from 1 to 1, weight from 1 to 2, 1 to 3, 1 to 4, 1 to 5. Then 2, 2 to 1, 2 to 2, 2 to 3, 2 to 4, 2 to 5. In this way, we will gonna compute this. So by seeing this graph, we can fill this D note and pi note very easily. In the first one, like in the pi matrix, pi 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, because the 5 vertices are here. Why we are writing the 1, 2, 3, 4, 5 in the rows and column? Because it's the all pair shortest path. We need to find the shortest path for each and every vertex to each and every other one, right? So in the diagonal, again nil, then whenever there is a direct path is given, the one is connected to each and every node, so the initial first row will be filled with one. If there is no indirect path, we will write here, right? So this is how we will fill by node R, right? Now let's come for D1. Now how the D1 works? The D1 says that considering the one as an intermediate vertex. If one is intermediate vertex, then the initial first row we will not update. Why? Because it is already having a starting vertex 1. So we will not consider this. Now coming to 2. Via 2. 2 to 1. Path is infinity. There is no path and we are considering only 1. So we will not update it. 2 to 2 will be 0. Now 2 to 3. There is a path infinity. So we will see whether there is a path from 2 to 3 via 1. Will it work or not? We will need to see this one. So let's see for this one. Now see here, 4 to 2. Path is infinity in the D node. 4 to 2. It means that there is no direct path from 4 to 2. But via 1 there is a 4 to 2 there is no direct path. But via 1 there is a path. We can go from 4 to 1, 1 to 2. The cost will be incurred 4 to 1, 2 cost, 1 to 2, 3 cost, plus 3, 5. And initial value we are having that is infinity. So the 5 is less than infinity, we will gonna replace this. Whenever you are updating this value by intermediate vertex, you need to update the respective pi value also. For example, here the 4 and see in the pi matrix, 4th row respective to the 2 and 3. Earlier it was 0, but now it is 1 because 4 to 2 there was no direct path, but now there is a path exists via 1. So 1 will be the ancestor here. We will gonna update this one. Similarly, see here 4 to 5. If you are gonna see in this graph, 4 to 5 there is no direct path, but 4 to 1, 1 to 5 there is a indirect path existing via intermediate vertex. So if you will see in the initial matrix 4 to 5 D node entry 4 to 5 C infinity, but we can replace it with the 4 to 1 post incurred 2, 1 to 5 minus 4, 2 minus 4 that is minus 2 that is less than infinity. So we will gonna update it entry 4 to 5. See the entry 4 to 5 that is changed by minus 2. Similarly, respectively change the pi matrix. It was earlier nil, now we need to fill 1. By a 1, we have considering it intermediate, the shortest path, right? Else there will be no change. So let's proceed for D2 and pi 2, considering 2 as an intermediate vertex. Now see, wherever in the pi matrix we will find 2, 2, it means that they are changed. Means that they are changed. For example, see here. Means that earlier there is 1 or either infinity. Let's see. 1, 2, 3, 4. So 1 to 4 there was no direct path, it was nil. But let's see, why there is exist a path via 2 or no. 1 to 4 there is no direct path, but via 2 there exists a path. That is 1 to 2 cost is 3 and 2 to 4 is 1. So overall cost will be 4. So we will update this entry in pi 2 by 4 and in the pi 2 matrix we will fill that the ancestor will be now 2. Right. Similarly, we will gonna keep on updating all the values 2 means via 2, considering 2 as an intermediate vertex. D3 means considering 3 as an intermediate vertex. 4 means considering 4 as an intermediate vertex. And 5 means considering 5 as an intermediate vertex. Now see here, in the D5, there is no infinity value. All the cells are having a value. It means that each and every vertex is reachable to each and every node via shortest path and via some other node, not the direct path if they are not existing. Similarly, see in pi 5, the 1 to 1 obviously it will be nil, but 1 to 2 there is ancestor is 3. It means that via 3 they are having the shortest path. 1 to 3, there is 4. It means 1 to 3, they are having the shortest path via 4. 1 to 4, 5 is the ancestor. It means via 1 to 5, there is the shortest path via 5. 1 to 5, there will be the via 1. It means the direct path is the shortest one. In the first row, we have see here the last entry is 1. It means the 1 is the direct path here. Similarly, in the second row, see wherever you will find 2, it means that is the direct path is the shortest one. In the third row, see by 3, there will be a 3 entry marked with the 3. It means that is the shortest one direct path. In the 4, there are 2 entries with the 4. It means that is the direct path is the shortest one. In the 5, there is a the 5 to 5 is the 5. It means there is no direct path to the shortest. Each and every is indirect path via 4 or via 3 they are having. In this way, we are trying to find out the minimum shortest path from each node to the other node while considering the intermediate vertex. That is how the concept is working here. And the numerical is coming in a similar manner. We have to solve the number of the nodes you are having. The similarly D matrix and pi matrix we have to form. Right. I hope that I made myself very clear. And sometimes the algorithm are also come. We have to write the algorithm and the overall complexity will be go and we're having the three loop, one inside another, and they're working till n. And n is the initialize with the weight of the basically, right? So the v is the number of the vertex, so the big of the overall complexity will be big of v cube. And in the next we will see the another problem that will be solved by this GP approach. Thank you. Thank you very much.